All right, it's time for our last review video, getting ready for our common assessment concerning our exponents and logs. This video is on solving log equations, and they're going to be of two types. The first type here is like number 1, where we have one log expression equal to a value. What we do is we rewrite this as an exponential. So I would start with my base, go get my exponent, and then set it equal to my argument. And then we are going to solve for x. So this would be 3 to the 7th subtract 9 is the same as 2x's. We would divide both sides by 2. So x is equal to 3 to the 7th subtract 9 divided by 2. And we might even want to get our calculator to figure that out. So we set up our fraction form. We use this caret button to get our exponent of 7, subtract 9, and divide by 2, and we get 1,089. The other problem on this page that is like number 1 is number 5 here. So we'll do that one next. Here we have one log expression equal to a number. We start here with our base. We know for natural log that's base e. Then we go get our exponent, which is 5, and we set that equal to our argument. And now we solve for x. So I have e to the 5th plus 1 equals 7x. I'm going to divide both sides by 7. I'll have x equals e to the 5th plus 1 over 7. This is my exact answer, but I could again use my calculator to get a decimal approximation. And when we use those squiggly lines, that means approximately. All right, the other log equations on this page look different. So we're going to do our second kind here, where I have one log of a same base equal to a log of that same base on the other side. One log equal to another log. What we can do then is ignore the log function and just operate with the argument. So this was like the case when we had the bases were the same and we had equal powers. Then we could just set the exponents equal to each other. I mean, these are essentially exponents being equal to each other. And then we would solve for x. There's a couple of ways to do this. The way I would recommend is to move everybody over and to use our special factor pattern, our identity here of a squared minus b squared. And then I will use my zero product property. And then I'll solve for x. So x would be 112 square rooted divided by square root 7, and x equals negative, or the opposite of the square root of 112 divided by the square root of 7. Now, when we are working with logs, we need to check our solutions. Not so critical with the exponential because we know the input to any exponential function is all real numbers. So we don't have to worry about checking our solutions. But here we know the log is not the case. We do not have a domain of all real numbers. However, in this case, this is positive, and if I squared it, it will remain positive. So this argument is positive, and 112 is not going to change its value. Likewise, if I square this, I will also become positive, multiplying a positive value. I remain positive, so this time we don't throw away any solution. So the rule is not to throw away any negative solution we would get. The rule is to evaluate each one of your answers to make sure that they're valid answers. Okay, we'll move on to number 3 because that looks suspiciously like number 2. I have natural log, so then I can just take x squared minus x equals 20. This time I don't have a choice on how to solve this. I have to move everybody over to one side and factor. And then I'm going to apply my zero product property. And I want to check each of my solutions. If I took 5 squared and took away 5, I would have 20. That's a positive argument, so that's good. If I have negative 4 and I square it and then I subtract 4 from it, essentially I have 16 plus 4, which is still positive. So again, I don't have to throw away a solution just because it is negative. And then we'll do this last one down here. I have a common log equal to another common log. So I have 5x plus 1 equals 2x. I'm going to take away 2 x's. Well, maybe let's take away 5 x's. That way we don't end up with the 0. Take away a 5x. I end up with 1 equals negative 3x. I'm going to divide both sides by negative 3. I get x equals negative 1/3. This time, when I go back and put it in here, this is okay. This would be, this would fail because you'd have negative 5/3 plus 3/3. That's going to remain negative. So you could stop right there. You wouldn't even have to check on the other side. Or you could have checked on this side and we still would have had the same issue. I'd have 2 times a negative 1/3, which would be negative 2/3. We cannot have a negative argument. So this equation has no solution. And we could prove ourselves correct by graphing common log 5x plus 1 and common log of 2x, and you would see that there is no intersection. The last type of problem, it really is like the first one we did, except we have a variable over on the side that's the exponent, not the side that's the log. So we're going to do this the same way, though. We're going to take 2, our base, to our exponent 5x, and then set it equal to 16. And if you remember from the previous video, the technique to solve an exponential is to find a common base, and we can do that this time. And set the exponents equal to each other, and then solve for x.